Today we're going to talk about graphing on the Cartesian plane or the coordinate system. This system is a system of a horizontal number line called the x-axis. There's a vertical number line that intersects that called the y-axis. Where these two lines intersect is referred to as the origin. That is also considered the zero on both lines. To the right of the origin, you would have positive values, 1, 2, 3, 4, and so forth. On the left, you would have negative values, -1, -2, -3, etc. On the y-axis, if you go up, you would have 1, 2, 3, 4, 5, etc. And if you go down, you would have negative values this way. These axes separate or divide a flat surface into 4 regions. The 4 regions are called quadrants. The quadrants are numbered starting in the upper right corner with a Roman numeral 1. And then you go counterclockwise. So this is Roman numeral 2, Roman numeral 3, and Roman numeral 4. This entire system was devised by a young Frenchman in his early teen years named René Descartes. He was sick and put to bed, and as a youngster who really would rather be outside running around, he glanced up at his tiled ceiling and created the system that we now know is the Cartesian system or the coordinate system. Now on this system, we will be graphing basic shapes using ordered pairs. An ordered pair is what René Descartes would have us to graph with, and that's simply a pair of numbers. The first number would represent the x value, and the second number would represent the y value. So if you were to graph the ordered pair 2, -3, then you would go on to the x-axis where there is +2, then down on the y-axis where there is -3. And you would place the point in the space that's open in that quadrant 4. Notice that that point corresponds to the x equals 2 and the y equals -3. Now we're going to take these individual points, if you would, from the ordered pairs and graph basic shapes. The basic shapes that we will look at include first a straight line. Now a straight line can actually go in 4 directions. You could have y equals x. All straight lines have an understood exponent of 1. And if that is a positive value of x, then that line is what we call increasing. It goes uphill, if you would, from left to right on the xy plane. Next, you could have a line that is going to go downhill, and that would be y equals -x, again with the understood exponent of 1. So if you have any negative value with x to the first, that would be a decreasing line. You can also have a horizontal line on the xy plane. A horizontal line is exactly that. It neither increases nor decreases, and so we say its slope is 0. And horizontal lines always have the equation y equals some number. And last but not least, you could also have a vertical line on the xy plane. Vertical lines have an undefined slope, and their equation is x equals any number. So you can basically tell from the given equation if the shape of the graph will be a line. and whether it will be increasing, decreasing, horizontal, or vertical. The next shape is a parabola. A parabola only occurs if you have an equation where the degree is 2, or x squared. Now there may be other values given with that, but the degree is 2. The exponent is 2. A basic parabola looks like the letter U, and some people say it looks a little like a horseshoe, just like this. You may recognize a symbol where two parabolas are taken and turned upside down. That's where McDonald's, that fabulous eating establishment, gets its golden arches. The next graphing shape is called the S-curve. If you have ever lived in the country and have driven a country road, you may know what an S-curve is. An S-curve graph always occurs when you have degree 3, or x to the third, even though there may be other values with that. The S-curve looks like this. It's as if it's a parabola on one side, but then it takes a twist or a curve in the middle and it continues down. Similar to what we say on a country road where there may be a twist in the road or a curve. This graph is an S-curve. The next graph is the V shape. A V shape will always occur when you are given an absolute value with the x value. Now notice it is x to the first, but it has absolute value. This graph is exactly as the name implies. It's a V. Now that V may be placed in different spots depending on how the equation was presented. Let's take an example. This is an example that would be very frequently used in homework. You're asked to graph y equals x squared minus 5. And out to the side, you're given a long table. And you're given these values, -3, -2, -1, 0, 1, 2, and then 3. Your first job would be to complete this table. So what you would do is take each value and substitute that in for the x, since those numbers are given as the x value. So the first one, I'd have -3 squared minus 5. Well, we know that's the same thing as a +9 minus 5, which is the same thing as 4. So for the first y coordinate, I would put 4 in its place. Then I would continue working the arithmetic for each given value. For the second value, -2 times -2 is 4. 4 minus 5 is -1. Then, with that -1 times -1, that is 1. And 1 minus 5 is -4. 0 is always easy to work with because 0 times 0 is 0. And 0 minus 5 gives me -5. You'll notice a symmetry start to appear when we use the positive values, because 1 times 1 is still 1 like a previous number, and 1 minus 5 equals -4. Notice both the -1 and the +1 x values yielded the same thing. That is a symmetry. Next, 2 times 2 is 4. 4 minus 5 equals -1. And last, we have 3, which is 3 times 3 since it's 3 squared. And 3 times 3 is 9. 9 minus 5 equals 4. Now, using these values, we would graph. I have -3, +4, and place a point. -2, and then -1. Negative 1 goes down to negative 4. 0 is at negative 5. That is what we call a y-intercept. 1 corresponds to negative 4, a symmetrical point. 2 corresponds to negative 1, that's another symmetrical point across from a previous one. And then 3 corresponds to positive 4. When we connect these values, you will see the U appear. This is a slightly thin or slender U, if you would. And remember, that is the parabola. Now, along with graphing, many times you are asked to state the x-intercept and the y-intercept, which I had just referenced. Remember, the x-intercept is where a graph crosses the x-axis, and its counterpart, the y-intercept, is where the graph would cross the y-axis. Here is an example. Let's say you have a curve that looks like an S-curve, but it's really a strange little S-curve. We have a point right here, a point right here, and we want to find the x and the y intercepts. First, the x-intercept. It is possible that a graph can have more than one x-intercept. If you notice here, we have the graph crossing in the center at 0 and over to the left at negative 2. So we would say both 0 and negative 2 are the x-intercepts. These can also be written in ordered pair form as 0, 0 and negative 2, 0. Commonly, when you write these in online homework, it'll say x equals what and just give you a box. You could just put 0, negative 2 and the software would understand that represents 2 answers. The order does not matter. Is there a y-intercept? If there's a y-intercept, normally it's just 1. And we do see the only place where it crosses the y-axis is at that center again. That can be the same for both x and y. So the y-intercept is 0, or you can write that as an ordered pair, 0, 0, or if you're working this online in a homework set, it will normally be y equals an empty box, and you would simply type in the number 0. I hope this has helped you understand graphing a little more. Good luck with your work.